So the very first thing we look at when we get started is how to access VASP at NERSC. VASP is treated differently from many other software items at NERSC because it is a licensed software. So for this, NERSC provides several pre-compiled VASP modules for the convenience of users so that you can spend your time doing science instead of trying to deal with the building software aspect of it. So to get access to VASP, initially, there's a short process. The first thing is you need to either own a VASP license or be registered on an existing VASP license, which usually means your PI or your group lead. And once you've been registered on a license, what you'll do is you'll fill out the VASP license confirmation form that is at the NERSC ServiceNow website. So once this form has been filled out, what NERSC will do is we'll contact the VASP vendor, which is either VASP GmbH or Materials Design, and then we'll check to see if you have a confirmed license. And then once it's confirmed from the vendor, we will add you to a file group that gives you access to all the VASP binaries that are in that file group. So if you're logged into Perlmutter and you type the groups command, you will see a list of groups corresponding to the project that you're in. And if you have access to VASP5, you should see the VASP5 group listed. And then if you have access to VASP6, you'll also see VASP6 in addition to this. One thing to point out is that the VASP6 group covers all of the versions of VASP up through VASP 6.4.3, but future versions 6.5 and on, which are not yet installed on Perlmutter, will eventually be either in a new group or the licensing will be done by a license key. All the discussion that I've had so far only applies if you want to use the pre-built binaries that are provided by NERSC. But if you're building VASP for yourself, and for instance, if you need a customized build, then there's no need to confirm license. It's only if you use the NERSC builds. Once you're on Perlmutter, if you type module avail VASP, you can see all of the VASP modules. And there are two different ways that these are classified. The modules that are just called VASP are come from the source code distributed directly from the VASP Corporation. But you'll also see modules that are called VASP-TPC, and the TPC stands for third-party codes. These versions of VASP have extra tools that involve modifying the source, namely the vtest code, which is useful for doing nudged elastic band calculations, and also the VASP-Sol code, which is used for solvation. Note that all of the builds, whether they are regular VASP or VASP-TPC, do include plugins that are enabled by precompiler options rather than by modifying the source of VASP. And these include tools such as Waynear90, DFT4, libxc, and Beef. As far as performance and parallelism of VASP, VASP can be parallelized in three different ways. The VASP5 executables all use pure MPI. And you can see there is a regular and a third-party code version of this. Then for VASP6, there are builds that target Perlmutter CPUs that have MPI plus OpenMP parallelism. And then there are also builds that target GPUs, which include OpenACC parallelism in addition to MPI and OpenMP. One thing to point out is that when using the plugins, not all of the plugins work for all of the builds. So some of the plugins, such as libxc and Beef, are not compatible with the GPU builds of VASP. And also the DFT-D4 utility is compatible only with VASP versions up through 6.4.2. But within these constraints, we generally try to enable as many plugins in the builds as possible. If you are looking at a VASP module and you want to learn more information about it, what it does, you can type the module show command. And in this example, I'm showing the VASP 6.4.3 GPU module. And when you type this command, you get a list of effects that it has on the environment. this has a few interesting pieces that could be helpful for your work. So first, you'll notice that there is a directory called the pseudopotential directory, which is the path to the potcar file. So if you need potcars, this is where to look. And then the other thing that's of interest is the makefile include path shows the makefile include that was used to build this particular version of VASP. So if you want to see how VASP is configured, or you want to copy this file to build it yourself, this file is not locked to group permissions. So you're free to copy it and then modify it as you wish if you want to build your own VASP. The other thing I'll mention is there are some paths to some extra utilities, such as the vtest scripts and batter analysis, which may be useful in your work as well. So these are also loaded whenever you load a VASP module. The other thing that you'll notice in the VASP module is a path to the binaries. And if you look in this path, you'll see three binaries: the gamma, the standard, and then the non-collinear. NERSC builds all of these for users' convenience. And just a couple of things that I want to point out about these. Occasionally, there have been users who have tried to run a calculation that requires non-collinear, but using either the gamma or the standard. And doing this throws this message: error, non-collinear calculations require that VASP is compiled without these two flags. So this is an indication that you're not calling the collinear version. So that NERSC actually built this version included in the module. So the only thing that a user needs to do is just switch executables that you're calling in your JavaScript. One more thing to note is that users that typically use VASP Gamma or VASP Standard sometimes will switch to non-collinear VASP NCL for non-collinear calculations. And note that the resources of non-collinear are higher than the other two versions. So if you're running this, you may need more CPUs or memory in order to complete your job. So just be aware of this if you're switching from standard or gamma to non-collinear. So finally, if you type module load and then your version, this will actually apply the environment in the module to your user session on Perlmutter. And then you can just, for instance, type VASP standard to launch VASP. And so in this case, at the bottom, I showed this. If you type which VASP standard, it shows the path that's in the module that you just loaded.